AI salesman, which contain the function as LLM recommendation and search. I do it using LangChain, PostgreSQL, and Pump LLM. So this is just like an application for Walmart that will have AI salesman to search for the buyers and according to their needs in English. And then we will also generate an item description for the seller and then can add to the platform too. So the dataset will be coming from a public dataset. It's from Kaggle. So the data structure is simple. So I will have a product table which contain the ID, name, description, and price. Then we will convert the description to some smaller chunk and then generate a vector embedding for each chunk and then store into the database too. And when the user enter the query, it will generate the embedding for the query and then search the closer matching. And then let's go to the codes. So firstly, it's just to install the necessary library and some setting. So the very first step is that first I load the database dataset to the DB. So this will contain the product ID, product name, description, and price. So the description actually is very long, as you can see. And then, so this is to connect the DB and generate a table which contain all the columns that I set just now. And then I put into the data. After that, I will convert all the description into a array, which like you can use the product ID as a matching key. The key is that we will chop all the description to 500 character, and then the result will become something like this. One product ID, if have a long description, then it will be multiple chunk. Then those chunk, I will convert them become embedding vector embeddings. So so this is the result that all the content become a embedding vector. Then I store those embedding vector to the DB2. So this is the second table that is we call product embedding, which contain ID and the embedding. So I insert into and then just to speed up the searching, I create the vector data the index to the vector database. The first one is with one of the type is called HNSW index. So this is the parameter. So I connect to the DB and then I create the index. Then I create another type of IVF flat index on the embedding table too. So this is the parameter. I create the index too. So this is just for the testing. If I want to search a card game with in a range price from 25 to 100. So again, I call the DB and then start searching, which is about in the range, and also the embedding also. So this is the result, like 24 to 100. So this is correct, and then this is the how we use the this hybrid search and recommendation. So for example, if we want to find a toy that can teach the letter to kids, so this is our searching query, and we want between 20 to 100 price range. Then we send the query to the vector DB. So it will search between the price range, and also it will matching the embedding from the query, like with the DB the description embedding. So this is like it will tell us the name of the product and the price and description. So this is the one that we will have the name, price, and description. So this is very messy, so that's why I use the LangChain to summarize and generate a high quality prompt. So it will summarize according to the templates. So this is our templates, a nicer templates. And then we convert the result, becomes something like this. It will tell us what is the toys and what is the price and what is the feature. So the second use case is like I am a seller, so I want to search a better description for my bicycle. So So I send this query and matching the similar description for this prompt, this query. So we will find that that's some thorough description also about the bicycle. Then it will create a nicer description according to the query. So it will introduce the bike. So how is it according to the description?